Okay, so the question is what happens if the ratio is negative? For example, sine theta equals negative 0.6. Do the rules for finding the repeated solution still work? Why or why not? Okay, let's start from there. So I'll be showing you my explanation and my worked example to show you why I believe it's still gonna work. Okay, so the first thing we see here is sine theta is negative 0.6. And the first thing you need to do is to solve for that. And so we see here that sine theta is negative 0.6, so theta is going to be negative 0.64. Okay, now that we have theta, we realize that in this case, sine is negative, so sine is going to be in quadrants 3 and 4. You can know this from using the CAS rule, because in quadrants 3 and 4, tangent is positive, and in quadrant 4, cosine is positive, which means in both of these, sine is going to be negative. Okay, so moving on. So if we're going to calculate these for quadrant 3 and 4, we know the rules are 180 degrees plus theta for quadrant 3 and 360 degrees minus theta for quadrant 4. So if we change those to radians, we know that's pi plus 0 quadrant 3 and 2 pi minus 0 quadrant 4. So in this case, it seems like it's not gonna work because the rules are switched, because the sine rule says it's supposed to be odd multiples of pi minus theta and even multiples of pi plus theta. So we see here that the rule is switched, but we're not finished yet. So when we move on, we plug in theta to find out what the values would be in quadrant 3 and quadrant 4. We plug those in, looking at the equation, that's pi plus minus 0.64, and that turns into pi minus 0.64. So we see here, because of the signs, now the equation has switched into pi minus 0.64, which gives us 2.502. And for the second one is 2 pi minus 0.64, which is 2 pi plus 0.64, and that equals 6.923. So as we've seen here, the rules have indeed stayed the same. The rules still work, because as mentioned earlier, the rule is for sine functions, odd multiples of pi has to subtract theta, and even multiples of pi add theta. Okay, even gonna show you the diagram right now. Looks something like this. And as you can see here, as mentioned earlier, we're going to try and find for the third and fourth quadrant these two here. And as you can see, the graph as well looks like it's supposed to be 3 pi, which is another odd multiple of pi, plus, because it's moving on before it intersects with sine is negative 0.6. And for 4 pi, seems like it's minus as well, because that's where it meets the line negative 0.6. But as shown already, once you plug it in, it changes to become pi minus 0.64 and 2 pi plus 0.64. So as you can see here, that also supports the fact that the rules still work. So the rules still work. Next question is, how do you ensure that you find all your solutions in a given interval? Well, it depends on what the interval is, for example. So let's say the interval was -2. Interval was, let's say, -2 pi 2 pi. What you would try to do, what I would do first of all, would be to find the value of negative 2 pi in decimals. So find the value of negative 2 pi, and we know that it's going to be negative 6.283 to 3 decimal places. So negative 6.283, and we know this is obviously going to be 6.283. So in order to keep up with this, any answer that you get following like what I had done earlier, for example, using the calculator, you find these 2 points, 2.502 and 6.93. You would immediately know that one of them only falls under the interval, which is 2.502, because 6.923 is greater than 6.283, which doesn't work with this. So the first step you would take is to firstly find what I would do anyway would be to change it to decimal so you can see exactly what you're working with. And so every answer you find in the repeated solution, always check it with the two endpoints, in this case negative 6.283 and 6.283. So that way any answer you get, which would probably be in decimals, you can always check it with these two figures and see if it fits in. If it fits in, which means, for example, it would be greater than negative 6.283 but less than that. So if it fits in, you know that that's a correct solution. And if it doesn't, it's greater than this figure or less than this figure, you know it doesn't work.